good morning. My name is Jibin, and Rebecca and I are going to talk to you about the shell industry process. Last week we kind of covered about what we're doing in the project. We're taking waste carpet, converting it to fuel, and the ash that they're giving us is hydrolyzed, so we don't have to worry about any problems with calcium oxide combustions. And as far as work being done on the project, we're taking it in two different directions. I'm doing the calcium hydroxide part, where the ash has calcium hydroxide present within the sample and we're converting it to calcium carbonate. So looking at that process, the first step is to charge it with carbon dioxide and then run it through a Clary fluctuator, where basically we're allowing it to sediment and then filtering it at the same time. So that device actually does both, and it's easy to obtain a faster reaction. And another idea is to add a aluminum flocculant where we're using aluminum sulfate, and there's a reaction shown below where we're converting the calcium hydroxide to the calcium sulfate ions, and then later on converting it back to calcium carbonate if needed. Because the overall project requires us to take as much calcium carbonate as possible from the ash to use it within the carpet industry. And what we've done this week is basically come up with the process flow diagram, and to talk more about it,
this is most of our process flow diagram. It has all of what Jimmy is talking about with the flocculation. Everything in the gray box is already at shop, and it either gives us the ash that we're using or provides us with a source for resources that we can use in the process. You can see his CO2 charger there coming out of the wet ash after hydrolysis. It feeds into the Clary flocculator where we're adding the alum flocculant, and calcium carbonate precipitates out. My process comes after his, where the junk at the bottom of the Clary flocculator is pumped into a spray dryer. That slurry, I'm going to show you a table and then come back. These are our starting points. We know what the ash is like when it's wet. We know what the ash is like when it's dry. We're making an assumption that the Clary flocculator will remove 40%, I know this is a huge table, I'm sorry, 40% of the available calcium carbonate from the calcium hydroxide and the plain old calcium carbonate already available. I converted the sample percentages which we were given for dry ash, not flocculated, converted it into dry mass based on molar values and stuff, and then removed 40% of that to get these values here. Pulled them over into, made a total weight, pulled it over into new percentages, which gives us a new dry weight of calcium oxide for me to work with. My process is working with the calcium oxide, his was the calcium hydroxide. 40% of what I'm getting is junk that has to be removed. Back to the process flow diagram. The first step and the first piece of equipment that I'm designing is a spray dryer. And I wish I could zoom in on it. Can I? No.
Try Control Plus. Okay.
It doesn't like it.
There you go.
I'm getting hot air from the exhaust from the plant. The slurry is sprayed in and you get vaporized, evaporated on its way down. It lands at the bottom of the drying chamber where the product is put onto a spiral conveyor, which is powered by a motor. Sorry, doing that. Gas that goes in is fed through the gas outlet. Any particulates that remain in the gas are put through a cyclone and down through a hopper, and the remaining gas is pulled into the atmosphere using the fan exhaust. That dried up stuff This is how I'm drying the wet product that he gave me. That dried up stuff goes into calcium looping, which I will explain next week in more detail when I have really shiny pictures. And that, I think, is all that I have. Whoa, our next steps. We have to iron out each step in our process flow diagram. We know what our starting masses are. We have to find out what they are at the end. Also the energy going in and out. After that, we need to tweak the equipment, make sure it is pretty flawless, find anything inside it that isn't behaving how we want, and then we can do the economic analysis. Are there any questions?